and welcome to Compound Measures with Qubits Education. In this lecture you will use definitions of speed, density, pressure and rates and convert between related compound units. So first of all, let's recap some measures we have already seen. So you might want to take some notes, especially because I've noticed that some of the work coming back to me, even though it might have been harder to submit sometimes, you haven't completed everything and haven't understood everything. So I would like you to take some notes during the remaining lectures, please. So 1 metre is equal to 100 centimetres. You need to learn these ones off by heart, okay? 1 kilometre is 1,000 metres. 1 kilogram is 1,000 grams. And 1 metre squared is 10,000 centimetres squared. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 hour is also equal to 3,600 seconds. 1 litre is the same as 1,000 centimetres cubed, as well as 1,000 centimetres cubed or 1,000 millilitres. And 1 metre cubed is equal to 1 million centimetres cubed. Okay, so pause the video at any point to take notes and to write some of these down. As I said, this one here, 1 litre, it's equal to 1,000 centimetres cubed and 1,000 litres, 1,000 millilitres, sorry. Okay, so the new measures we're going to look at are compound measures. So here's some examples of compound measure. So speed is the distance travelled per unit of time. So speed is one of our compound measures. For example, a cyclist travels 400 kilometres in 8 hours, and we must remember we need to work out his average speed. So if we've got to do that, we must remember this formula: speed equals distance over time. So again, make sure you write that down in your notes. So speed equals distance over time. Our distance is 400 kilometres and our time is 8 hours. So 400 divided by 8 is 50, and we have to put kilometres per hour because it's kilometres per hour. Okay? So his speed is 50 kilometres per hour. Another example then is density. That's another compound unit. So for example, density is the amount of mass per unit of volume. So that's how heavy it is per unit of volume, per centimetres cubed or metres cubed or anything like that. So an example question: a bath sponge is roughly a cuboid, which is a 3D rectangle for those that can't remember. It's 10 centimetres long by 8 centimetres wide by 3 centimetres thick, and its mass is 180 grams. In order to work out density, we need to know the volume first. So when we're going to work out the volume of a cuboid, all we have to do is length times width times height or thickness. So its volume is 10 times 8 times 3, which is 240 centimetres, okay, cubed. This cubed means that we've had 3 measurements, okay, in simple terms. So its density then is mass divided by volume. Well, we know the mass, it tells us in the question, it's 180 grams, and its volume we've just worked out here is 240 centimetres cubed. You would also do well to write down this formula to remember that and revise it. So 180 grams divided by 240 centimetres cubed is 0.75 grams per centimetre cubed. Okay, 0.75 grams per centimetre cubed. These will be on the calculator papers. You won't be expected to do that division without a calculator. So the density of the sponge is 0.75 grams per cubic metre. Okay, so a third compound unit you may not have come across is pressure. Pressure is the amount of force per unit of surface area. So that's how much force is applied to a surface like a ground or table, but it's per unit of surface area, which you might well have guessed it means we need to work out the area as well first. Sometimes it gives us the area, sometimes you might have to work it out. So for example, a man weighs 800 newtons and his footprint covers an area of 0.05 metres squared. Okay, so this is how much he weighs in newtons. okay, which is what we use when we calculate pressure, and this is the surface area that it covers. Okay, so we don't actually have to work anything out, it's told us the surface area. So how much pressure does he put on the floor when he stands on his feet? Now, the formula for pressure, another one you need to write down, is force divided by surface area. So we know the force, which is 800 newtons, and we need to divide that by the surface area given in the question, 0.05 meters squared. Okay, if we do 800 divided by 0.05 newtons, it gives us 16,000 newtons per meter squared. So for every meter squared, the force is 16,000 newtons, okay, per square meter. Oops, sorry. 1 newton per square meter is written like this, as you can see, okay, and we call it a Pascal. So even though we're writing it like this, 16,000 newtons per meter squared, we can also call it a Pascal, 16,000 pascals. Okay, so this is 16,000 pascals as well. Okay, so let's have a look at a few questions then. Please feel free to pause the video and have a go at them, and continue through to see the working out if you think you might have made a mistake. In 2009, the athlete Usain Bolt set a world record by running 100 metres in 9.58 seconds. What was his speed? So we should remember that speed equals distance divided by time. His distance was 100 metres and his time was 9.58 seconds. So we need to do 100 divided by 9.58, giving us 10.43841,336,1169. So if I round that up to 3 decimal places, or round it to 3 decimal places, sorry, it's 10.438 meters per second. So in every second, Usain Bolt can run over 10 meters, which is absolutely astonishing. The speed limit for traffic outside schools is usually 30 kilometers per hour. Would Usain Bolt break the speed limit? Okay, so the two speeds then are in different units. So we know that Usain Bolt runs at a speed of 10.438 meters per second, and we know that the speed limit is 30 kilometers per hour. So the two speeds are in different units, which means we need to convert one of them to make them the same. So what we're going to do first is convert meters per second, so Usain's speed, to kilometers per hour, the speed limit. Usain's speed is 10.438 meters per second, so every second he can run over 10 meters. I need to take his speed and times it by 60. Okay, that will tell me how many meters per minute that is, which is 626.305. Okay, so now that's in minutes. So I've times by 60 because there are 60 seconds in a minute. So now what I'm going to do is I'm going to have to times that by 60 again, okay, that number now, that answer, to give it me in hours. So I've gone from seconds to minutes to hours just by timesing by 60 twice. So that now gives me 37,578 meters per hour. So finally, what I need to do is change my meters to kilometers. Well, there are 1,000 meters in a kilometer, so I need to take my answer here and divide it by 1,000. Okay, there are 1,000 meters. So that gives us 37.578 kilometers per hour. Okay, that's what speed he was running at. Our speed limit is 30, so Usain would be breaking the speed limit. Okay. Now, what we've just done is changed meters per second, his speed, to kilometers per hour. We did that by timesing by 60 twice and then dividing by 1,000. You must understand the reason why we've times by 60. We've done seconds to minutes by timesing by 60 and minutes to hours by timesing by 60. And then we did meters to kilometers by dividing by 1,000. Okay? Okay, so what we're going to do now is we are going to do kilometers per hour and we're going to change that to meters per second. So we know that Usain Bolt has a speed of 10.438 meters per second, and we're going to convert the 30 kilometers per hour speed limit to meters per second to see if he was running over the limit. So our speed limit of 30 kilometers per hour, we're going to times it by 1,000 first to give me meters per hour. I had kilometers, times it by 1,000, now gives me meters. Okay, so 30 times 1,000 gives us 30,000 meters per hour. Okay, so every hour Usain Bolt can run 30,000 meters, which is really far. Okay, so now what I'm going to do is take my hour part and change it to minutes. So I'm taking my 30,000 and I'm dividing it by 60. 30,000 divided by 60 gives us 500 meters per minute. So we've gone from hours to minutes because there are 60 minutes in an hour. Now, finally, I will have to divide that by 60 again to change it to seconds. 500 divided by 60 is 8.33 meters per second. Okay, so Usain was running at a speed of 10.438 meters per second. The speed limit, when converted to meters per second, is 8.33. So he was definitely breaking the speed limit. Okay, so what I want you to do now is, using those two methods, which I'm sure you've written down copious notes on, is pause the video and have a go at filling in the boxes. So you're changing meters per second to kilometers per hour or back again. Okay, so if you've paused the video and had a go, let's have a look at the answers. So 2 meters per second is 7.2 kilometers per hour. 10 meters per second is 36 kilometers per hour. 50 kilometers per hour is 13.9 meters per second, and 800 kilometers per hour is 222.2 meters per second. Okay, if you got all those right, well done. Really impressive. Okay, so for this one, a rowing team is rowing down a river at 22 kilometers per hour. A woman is jogging along the path beside the river at 6 meters per second. Complete the table and tick which one is fastest. So I would like you to pause the video and on paper have a go at working it out, and try and fill in the table, and then I'll come up with the answers. Okay, if you've had a go, 22 kilometers per hour is 6.1 meters per second, and 6 meters per second is 21.6 kilometers per hour, so the rowers were the fastest. Okay, so here's another question. I would like you to have a little go at it, but it is tricky. So I'll read the question out and you can pause the video and have a go, and then I'll go through it. A wooden log has a volume of 1,600 centimetres cubed, and its mass is 700 grams. A solid plastic replica log is the same size, but has a mass of 1.8 kilograms. Water has a density of 1,000 kilograms per metre cubed. Will either log float? If you want to pause the video, please do so now. Okay, and we will go through the answers. So, a quick hint: an object floats if it is less dense than water. If it sinks, it is more dense. The density of the wooden log, which is the first thing we have to figure out. So you must remember your density formula from earlier on in the video that you wrote down on your notes. Density of the wooden log, or density, is mass divided by volume. A wooden log has a volume of 1,600 centimetres cubed. Great, we can put that in there. And a mass of 700 grams. There we go. So all we need to do is 700 divided by 1,600, giving us 0.4375 grams per centimetre cubed. Okay. There are 1,000,000 centimetre cubed in a metre cubed. Okay. Now the reason you need to know that is because in order to know whether this will float, we need to know if this is going to be more dense than water, and water is in kilograms per metre cubed. So we need to times this by 1,000 to put it into grams per meter cubed rather than centimeters cubed. Okay, so 0.4375 times a million grams per meter cubed is 437,500 grams per meter cubed. The last thing we need to do is put it into kilograms. 1 gram is 1/1000th of a kilogram. Okay, so basically there are 1,000 grams in a kilogram. So we're already in grams, so we need to divide by 1,000. If we do 437,500 divided by 1,000, you get 437.5 kilograms per meter cubed. Okay, so that is less dense than water, which means it will float. Okay. Okay, so let's have a look at the plastic log now. To work out the density of a plastic log, or of anything, is the mass over volume. The log is the same size but has the mass of 1.8 kilograms, which goes there. Okay, so it's exactly the same size, which means it has the same volume, 1,600 centimeters cubed. 1.8 divided by 1,600 is 0.001125, okay, and that's in kilograms per centimeters cubed. So we need to change this centimeters cubed to meters, which means we need to times this by a million, giving us 1,125 kilograms per meters cubed. Now you might have noticed that this is already in kilograms, okay, it wasn't in grams, so we didn't have to divide by 1,000 to make it into kilograms, it's already there. Now this is 1,125 kilograms per meter cubed. Water has a density of 1,000, which means it is heavier, okay? So this means that the log is more dense than water and would sink. We could also answer this question by converting all units to grams per centimetre cubed. So water density is 1,000 kilograms per metre cubed. So we can take that 1,000 and to change it from meters cubed to centimetres cubed, we divide by a million. Okay, so that gives us 0.001 kilograms per centimetre cubed. Now we need to turn this into grams. So we need to divide by times by 1,000. Okay, so 0.001 times 1,000 is 1 gram per centimetre cubed. The plastic log density, if it was 1,125 kilograms per metre cubed, we would then times it by 1,000 to turn it into grams, which would give us 1,125,000 grams per metre cubed. But it's still in metres cubed, so we need to turn it into centimetres cubed by dividing it by a million, giving us 1.125 grams per centimetres cubed. Still heavier than water, obviously, so it'll still sink. Okay, we worked out the wooden log density earlier as 0.4375 grams per centimetre cubed. Okay, so water, 1 gram, wooden log, 0.4375 grams, and the plastic log, 1.125 grams. The table shows that the wooden log will float and the plastic log will sink. So let's have a quick summary of density. To convert grams per centimetre cubed into kilograms per metre cubed, and I suggest you write these down, you would times it by a million first to turn your centimetres cubed to metres cubed. You would then divide by 1,000 to turn your grams into kilograms. Okay. Now, you might realise that timesing by a million and then dividing by 1,000 is actually the same as timesing by 1,000. So you could have just times by 1,000 and it would have given you your actual answer. To convert kilograms per metre cubed into grams per centimetre cubed, so the other way around, we times by 1,000 to turn our kilograms into grams, and then we divide by a million to turn our metres cubed to centimetres cubed. Okay, so I would like you to pause the video and have a go at filling in the boxes. Obviously you're just doing it on paper for now, but just have a go and press play when you're ready. Okay, if you have had a go, here are your answers. So, air has a density of 0.0012 grams per, it's meant to have a slash there, centimetre cubed, is the same as 1.2 kilograms per metre cubed. 0.25 grams per centimetre cubed is 250 kilograms per metre cubed. 2,500 kilograms per metre cubed is 2.5 grams per centimetre cubed. And 11,350 kilograms per metre cubed is 11.35 grams per centimetre cubed. If you got all those right, well done. That is a complicated topic. Okay, so not too much more to go now. Let's have a look at this question. Circus elephant weighs 60,000 newtons. The area of his foot is 0.12 meters squared. What is the pressure? We also have a lady dancer. She weighs 500 newtons and the area of her foot is 0.8 centimeters squared. Does the elephant balanced on one foot or the woman in high heels cause more damage to the floor? We can find out by calculating the pressures and comparing them. So earlier on we looked at the formula for pressure. The formula for pressure is force over surface area. Okay, so the force here is 60,000 newtons because that's what he weighs. And the surface area is here, area of his foot, 0.12 meters squared. Okay, so we just need to do 60,000 divided by 0.12. Okay, if we do that, it gives us 500,000 newtons per meter squared. Okay, so we'll just come back to that in a second. Let's have a look at the female dancer. So she weighs, the formula, for pressure is force over surface area again. The force is 500 newtons and the surface area is 0.8 centimeters squared, as it all says in the question. You will find that if you read questions carefully, you will find everything you need to answer them. Okay, so 500 divided by 0.8 then gives us 625 newtons per centimetre squared. Now, when we did the elephant, his was in metres squared, so we need to turn this now into newtons per metre squared. There are 100 times 100, which equals 10,000, centimetres squared in a metre squared. Okay, 100 times 100, so 10,000. So we need to do 625 times 10,000, okay, which gives us 6,250,000 newtons per metre squared. Now if we compare those two, we have the elephant, who, I think it was just over 1 million. Let's just quickly go back and check his answer. Sorry, 500,000. So the elephant only exerted a force of 500,000 newtons per metre squared, whereas the dancer exerted a force of 6,250,000 newtons per metre squared. So the lady dancer, or the female dancer, will probably leave dints in the floor, and the elephant might make the floorboards bend a little bit. And although the elephant is obviously heavier than the dancer, her heels pointing such a small amount of pressure in one area is more likely to create more damage than if you spread the weight, which is why elephants and polar bears and things have such wide feet. It spreads the area over, soft ground. Okay, so a quick summary then. A Pascal is 1 Newton per square metre. So if we're measuring anything and we come out with newtons per metre squared, you can also call it a Pascal. To convert newtons per centimetre squared into newtons per metre squared, we must times by 10,000. Okay, to change those centimetre squares to metre squares. However, this only relates to squares. If it was just centimetres to metres, we times by 100 because there's 100 centimetres in a metre. But because we're dealing with square centimetres and square metres, we have to times by 10,000. To convert newtons per metre squared back into newtons per centimetre squared, I'm sure you've guessed it, we divide by 10,000. Okay, so I'd like you to pause the video and have a go at changing these newtons per centimetre squared 2 newtons per metre squared, or 2 pascals. Okay, if you've had a go, here are your answers. So 10.25 newtons per centimetre squared is 102,500 pascals. 1.8 newtons per centimetre squared is 18,000 pascals. 450,000 pascals is 45 newtons per centimetre squared. And 500,000 pascals is 50 newtons per centimetre squared. Now then, 3 more questions I think I've got left for you, just to make sure that you are fully understanding the topic. Now, any measurement described as a rate will be measured in a compound unit. So, for example, a rate of pay could be measured in pounds per hour or pounds per annum, which is pounds per year. A rate of flow could be measured in litres per second or cubic metres per hour. So, if your tap's dripping and in 1 second you lose 0.02 of a litre, then that's what it's measured as. The cost of buying bulk items could be measured in pounds per 100 items or pence per kilogram. Mabel works in an office. Her rate of pay is £15 per hour. She works 30 hours per week. Her weekly rate of pay is 30 times 15, because she works 30 hours a week at £15 an hour, which is £450. So that is her rate of pay per week, her weekly rate of pay. Now, she's paid for every week of the year, including holidays. Her annual rate of pay is the £450 that we previously worked out per week times 52 weeks in the year, which is £23,400. So her annual rate of pay is £23,400. Her wage is paid into her bank monthly. Well, it's the same amount each month, so we need to divide her yearly wage, which is £23,400, by 12, which is £1,950 per month. So that's just some examples of a rate of pay. Now, if water is flowing from a tap at a rate of 20 litres per minute, okay, so this is like a rate of flow, 20 litres per minute, that means for every minute that tap is running, you are losing 20 litres of water. What would the rate be in litres per hour? Well, if it's 20 litres per minute, there are 60 minutes in an hour. So we need to do 20 times 60, which gives us 1,200 litres per hour. Okay. What would the rate be in centimetres cubed per second? Now, this is a tricky question, and it's just one to catch you out. There are 1,000 centimetres cubed in a litre. Okay, we have 1,200 litres here. There are 1,000 centimetres cubed in a litre. So we need to take our 20 litres per minute, and we times that by 1,000 centimetres cubed. Okay, because it's 20 litres every minute. Okay, so 20 times 1,000 centimetres cubed is 20,000 centimetres cubed per minute. Alright, so we just times that 20 by 1,000. But that's every minute. I want to know what it is per second. So, to change minutes to seconds, we know we need to divide by 60. So 20,000 divided by 60 is 333.33 centimetres cubed per second. It's all about time and how much of the smaller item is in the bigger item. So what I mean by that is how many centimetres are in a metre, or how many minutes in an hour, or how many millimetres in a centimetre, something like that. How many of the smaller things are in the bigger things, and that's what you times or divide by. Okay, last one then. Loose sweets in a jar are sold at 95 pence per 100 gram. What is the price in pence per gram? Okay, so 1 gram then, 95 pence per 100 grams. Well, if it's 95 pence for 100 grams, I want to know what it is for 1 gram. So I'm going to do 95 divided by 100, which is 0.95 pence per gram. So now, what is the price in pounds per kilogram? So 1 kilogram is 10 times 100 grams. 95 pence per 100 gram is 95 times 10 pence per kilogram, which is 950 pence per kilogram. Okay. And then 1 penny is one out of 100, or there's 100 pennies in a pound, so we do 950 divided by 100 pounds per kilogram, which is £9.50 per kilogram. Okay, so well done, and thank you very much for using Cubit Education. I'll see you next time.